Okay, see if you can do this one here. Similar to the previous video. So the probability of it raining on any given day is zero point 0.3. Of it not raining is 0.7. But in the previous video, it was 2 consecutive days. I wanted to know what is the probability of it raining at least once on 3 consecutive days. Meaning, for example, let's say 3 days next to each other. So Tuesday, Wednesday, and Thursday. Um, well, it could rain, not rain, not rain. So this is a good outcome because it's at least once. So it rained at least once here. Okay. So this is also another good outcome. Rain, rain, rain. This is a good outcome because it's classed as at least once because it rained at least once. Okay. So anyway, but here, similar to the previous video, but you've got 3 consecutive days. So it's pointless doing the table diagram because this would represent your first day. This would represent your second day. But how would you represent your third day? So the table diagram breaks down. Whereas if you use a tree diagram, first day, second, and then second day, okay, and then on your third day, it could branch out even further, okay. Well, this here would represent your third day. If you want 4 days, branch out even more. So even though the tree diagram seems a bit more complicated, it's a lot more useful than the table one. The table one's good when it's for simple probability problems, but this one is getting complicated now. We've got 3 consecutive days. So press pause and try and work out the probability of it raining at least once on 3 consecutive days. But by the way, there might be a shortcut. So think about it. Okay. So press pause and have a go. Okay. So to do this here, draw a map of all the things that could happen. So let's say you start here. It could rain or not rain on your first day. Rain, not rain. Okay. Let's say it rained on your first day. Then it could on your second day it could rain or not rain. Okay, and then on your let's say it rained, and on your final day it could either rain or not rain. Okay, and well okay, let's go back to the beginning here. You start here. Let's say it doesn't rain. Okay, and then on your second day it could either rain or not rain. Okay, let's go back to the beginning. It didn't rain, it didn't rain. So on your final day, it could either rain or not rain. Okay, let's go back to the beginning. Let's say it rained on your first day, not rained on the second day. On the third day, it could either rain or not rain. Okay, let's go back to the beginning. If it on your first day, it could, let's say it doesn't rain, it rained. And then on your third day, it could rain or not rain. So again here, this is a map of all the things that could happen. You are in effect have just drawn a map of all the things that could happen. So here, this would be a good outcome because the question is saying at least once, it raining at least once. This is a good outcome because it rained, and sorry, rained, not rain, rained. So this is a good outcome because it rained at least once. Probability of it raining, this is a good outcome. This is a good outcome because it rained once here. This is a good outcome. It rained once here. Okay, this is a good outcome because it rained on the third day here. Well, this is not a good outcome. Okay, so basically you got to add up this branch. Well, you got to get how this is 0.3, 0.7. This is 0.3. This is 0.7, and so on, 0.3. So you need this. Well, basically to get this rain, you got to get 0.3 and this and this. So basically you got to times all three together. Okay, so all right. So you need this branch here. So probability of it, rain, 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 would be 0.3 times 0.3 times 0.3. That would be, hang on, jump to a calculator, hang on. So it would be 0.3 times 0.3, hang on, 0.3 times 0.3 times 0.3 equals 0.0, what was it, 27. Okay, and then you need probability. You need this branch now. So probability of rain, rain, and not rain. So basically, you need this times this times this, and then you gotta add all these up, because you've drawn a map of all the possible things that could happen, and because the question is saying you need to know the probability of it raining at least once. You need all these branches except from this one here, not rain, not rain, and not rain. So this would be 0.7, 0.7. So rather than working out all these branches and adding them all up, I'm just going to get one take away the probability of not rain, and not rain. It's a lot quicker than adding up all these branches together. Okay, because we know that we've drawn we know that if you add up all the branches, it must come to 1, because you've drawn a map of all the possible things that could happen. And if you take one branch, then, well, if you add up all the branches, it comes to 1. I know that I need all the branches except from this one here. So I'm just going to work out this one here and just get 1, take away this branch here. Okay, so probability of at least once equals 1 take away the probability of not rain, not rain, not rain. Okay, so 1 take away, well, probability of it not rain, not rain, not rain would be 0.7 times 0.7 times 0.7. So hang on, calculator, clear. So 0.7 times 0.7 times 0.7 equals 0.343. Okay, so I just need to get 1 take away that thing. So 1 take away 0.343 equals this 0.657, was it? Yeah. So the probability of it raining at least once is given by this here. Okay. It just so happens that if you add up all these branches here, it should come to the same answer. If you add up all these branches here and this last one here, then it should come up to this. But rather than doing that, just work out the branch that you don't need, and just get 1 take away the branch that you don't need. Okay. So anyway, the answer is given by this.